Hey there, my name is Riku. I'm the technical architect for the OpenCRVS project. In this video, we will be going through the 3 different methods for setting up HTTPS for your OpenCRVS environment. The method you choose depends largely on the security requirements of your environment. So in production, we will have to use a different mechanism to what we are using, for instance, in QA or dev environments. It also depends on the existing IT infra of your government and the maintenance processes that you want to establish in your project. OpenCRVS provides 3 different ways for setting up TLS, so HTTPS certificates. 2 of these methods involve Let's Encrypt, a non-profit organization that issue HTTPS certificates for websites for free. Now that you have set up your QA environment, you might have noticed that you didn't have to do anything special to get HTTPS working. This is because for dev and QA environments, OpenCRVS actually does everything for you. The story is a bit different for production environments where we have stricter security policies in place. Now let's dive into the 3 different ways of configuring HTTPS for OpenCRVS. Option number 1. HTTP challenge with Let's Encrypt. This method involves using Let's Encrypt in conjunction with what's known as the HTTP challenge. To issue a certificate, Let's Encrypt must first verify that the domain it's being issued to is actually owned by you. The HTTP challenge involves Let's Encrypt making an HTTP request to your domain, which must be answered correctly by your server to prove that it's yours. This is the simplest method, as traffic, the software component we use for reverse proxying and load balancing, can automate the process for you, as long as it knows the domain names you want to be using. This method is typically suitable only for QA and development environments, because it requires Let's Encrypt to be able to make an HTTP request through the public internet to your environment. In production environments, this is not recommended. So, before we discuss option number 2, let's take a moment to discuss the security of your OpenCRVS application. Your OpenCRVS environment should always be deployed to a private network that can only be accessed via VPN. It is critical to note that neither the OpenCRVS software nor the provided reference infrastructure can ensure that your environment is not accessible on the internet. This type of firewall configuration should always be done at the level higher than your application servers, so at the level of the data center, by your system administrators. So let's take a quick look at the OpenCRVS network diagram so that you can get an idea of what the networking should look like. The networking configuration is highly dependent on the IT infrastructure and the existing networking setup, the data center, and many other factors that can apply only to your specific country. On the right side of this diagram, we can find all the application servers and the backup server. Each of these servers are inside of their own internal networks, safeguarded by firewalls that are configured to only let traffic in from specified networks. These specified networks are the network A for the end users, that the end users will connect to whenever they are using their VPN, and network B, that is for all of the automated clients. In the context of this video and setting up HTTPS, This is enough for you to understand that the certificate issuing method number 1 does not work in production environments, because Let's Encrypt will exist on the public internet and would have to make a connection to our application servers through one of these internal networks to which it doesn't have access to by default. If you do not have prior experience in configuring infrastructure network, you can use the OpenCRVS provided diagram as a specification for an infrastructure expert. Now that we have verified that your production OpenCRVS environment is not accessible from the public network, we can move on to the option number 2 of the HTTPS certificate setup. Option number 2 is a DNS challenge. This approach involves setting up specific DNS records that allow Let's Encrypt to verify domain ownership. Let's Encrypt will generate a random passphrase that you'll need to add as a TXT record in your domain's DNS settings. Usually this would be done through the DNS services admin panel, but in this case, as we need the TLS certificates to be automatically renewed every 3 months, we cannot do it manually. This is why the DNS provider needs to support an API for doing this. If your DNS provider supports API integration for updating these records, this process can be fully automated, making it a viable option for environments where manual updates are not feasible. You can find the full list of supported DNS services from the Traffic website. Option number 3 is using a pre-issued TLS certificate. In many cases, governments already have TLS certificates that are used in all software that is deployed. This third option involves using TLS certificates that have already been issued and are stored as certificate files. These certificates are stored on the encrypted file storage partition on the application servers, and the server is configured to know their exact location. This method requires manual renewal of certificates, typically once a year. Let's look at how option number 1 looks like in practice. In your country config repository, there are different deployment files for each environment. In these files, there is a section that configures the reverse proxy traffic. In this section, you will usually find also how the DNS challenge or the DNS mechanism is configured. I mentioned QA environment being configured automatically, and you can find the configuration from here, from the beginning of the file. These 4 lines of configuration instruct traffic to use the automated certificate management environment, abbreviated as ACME. The configuration line that defines the HTTP challenge mechanism is this one. These are the only lines of configuration you need for enabling this mechanism. Additionally, for each service in the stack, a domain is being configured. If you open up Docker Compose deploy.yml and we look at, for instance, the config service, you'll see that traffic is also configured to be using the config.yourhostname domain. There is also a configuration here for TLS that makes it so that TLS is resolved by the cert resolver that we had defined in the Docker Compose QA deploy file. As for the second DNS configuration option, let's look at the staging deploy.yml. In this configuration, we see some differences to the configuration we just saw for the QA environment. For instance, here we have defined a Google Domains access token. In the list of supported DNS providers we saw earlier, you also find the environment variable names that you will need to be using for the DNS provider of your choosing. The configuration lines for traffic look quite similar to what they were for the HTTP challenge. The only real difference is the DNS challenge provider set to Google Domains. In your case, this might be something different, like Cloudflare, for instance. These are the only changes you will need to make to get the DNS challenge working with your DNS provider. As for the third option, pre-existing TLS certificates, you can read through this comment in this file. Inside of this comment, you will see both the configuration lines you will need to be setting up for traffic, and also the volume link to the certificates directory in the encrypted data partition. Once you have placed the certificate files to the right directory with this configuration, Let's Encrypt should automatically start using your certificate files instead of the automated mechanisms.